Hello guys, welcome back to another video. I will be doing functions for grade 10 to grade 12. So I am going to be starting to explain the different functions slowly, how to find the xy coordinates, how to calculate the turning points for the different functions, etc. So that's what I will be doing. And if whether you are in grade 10 or in grade 11 or grade 12, this video would really benefit you if you are doing maths, because I will be tackling issues, core issues of functions and making examples. So I'll not just be doing grade 10. I'll start slowly where it's grade 10 and I will tell you where now what do we do in grade 11 and what do you do in grade 12. But in grade 12, the only thing that is different for functions in grade 12 is that grade 12 you're not getting introduced to inverse, but in grade 11 and grade 10 there is no inverses. So that's the only difference. So when you know grade 10 and grade 11 functions, you know your grade 12 functions. So it's very important that if you're in grade 12, you watch this video. It will help boost your marks a whole lot when it comes to functions, and you get confidence in this June paper. Now, without wasting any time, guys, let's get into the video. So now I'm gonna be starting with this 3 types of functions, so that when we get to grade 12, then we will advance more into log functions and so on. So I'm gonna start with the basics, which is linear functions. That is a straight line. Functions y equals to mx plus c, we all know that. And then from there I will go to quadratic functions, which are our parabola, and then from there we will go to our hyperbolic functions, which are our hyperbola. And then we will also, which I forgot to write, we'll also do exponential functions. So that's what we will be doing together today. So let's start with linear functions. What are linear functions? All right, so we are going to start with linear function, which has the equation of y equals to mx plus c. So this m is the gradient, which you find it by using the analytical geometry equations. This y2 minus y1 over x2 minus x1. So this is how we find that. And then the c is the y value, right, that cuts the graph, right? That is c. Now let's say you are given this graph over here. This is 1, this is 2, this is 3, right? This is also 1, 2, 3, -1, -2, -3, -1, -2, -3. And then the coordinates here are 3 for x and 3 for y, and then -1 for x and -2 for y. Now we having this graph, we are asked to determine the equation of this graph. This is a straight line. Grade 10s, grade 11s, and grade 12s. When you see a straight line on a function, know that it is a straight line, right? Yes, that is a straight line. That line, that is g, it's a graph of g at x, it's a straight line. So the first thing you will do when you are asked to determine the equation of a straight line is that you will take your coordinates on the graph, we have -3 and 3, and then there we have -1 and 2. We substitute them into this equation, then we get our gradient. The gradient is 5/4. Then after, you will need to find your y. So here we have our gradient. We write it like this, and then we need to find y. Y is this point where that graph cuts on your y-axis. You see this? It's C. Sorry, not y, it's C. This point here is C. So that is what we are trying to find. So because it's on the negative, we can substitute -1 and -2 to find this. It's 0, something. You see, just before 1. So we will substitute -2 as y, and then we'll substitute -1 as x. Let me write it. Yes, so we have these values on the graph. We can just say -2 equals to 5/4 into -1 plus c. So we will get -2 equals to -5/4 plus c. So to solve this, we can multiply everything by 4. So we can say -2 times by 4 equals to -5/4 times 4 plus c times 4. So we have calculated everything so that we can cancel this 2. Then here we will have 8. It's equals to -5 plus 4c. You see? So this 5 will come. This 5 will go the other side, and that will have it's negative. This yeah, it's 4. 4 times -2, that is 4 times -2, that is -8. So we'll have -8 times 5, because when this 5 comes this side, it will change. Sorry, not times, plus -8 plus 5, and that will give us -3. So this will be -3, because this 5 will come this side. It will change the sign. It will be plus. -8 plus 5 is going to be equals to 4c. Now we want 4. We want c. We'll divide by 4 to get rid of that 4, and then -3/4 will be the value of c. So the new equation will be y equals to 5/4x plus -3/4. So this sign of this negative will affect the whole thing, right? So you will have y equals to 5/4x minus 3/4, because it will affect that sign. That was quite easy, right? So when you are given a graph and it's a straight line and you're asked to determine the equation of that graph, you firstly have to use the 2 points that you're given on the graph to find your gradient. After finding your gradient, you substitute it, use the points that will give you the required results. So here we have -3/4, because that line cuts on the y-axis on a negative y-axis. So hence why this is negative. Yeah, that is what you do. You find the gradient. After finding the gradient, then you substitute any points to find the value of c, and this is how you have to write your equation. When c is 0, it will just cut at 0 and you will not have anything. Just have y equals to, if you have this, y equals to 5/4x. Just know that line cuts the y-axis at 0. Okay, still on linear patterns, how to get x and y intercepts. So we're just given a graph, a straight line and you are given the equation, let's say y equals to 5. Let's say y equals to 5. Okay, no, that's not this one. Let's say y equals negative 2x plus 4. And we are asked to find the x and the y coordinates. Okay, so to get x, y equals to 0. To get y, x has to be equals to 0. So how does that even work? Where to get x, y has to be 0, right? So we say 0 equals to negative 2x plus 4. So we will say negative 4 come this side equals to negative 2x, and then we will divide by negative 2 on both sides, and that will be negative 4 over negative 2, and that will give us a positive 2 equals to x. Now let's say we want to get y. We'll say y equals to negative 2, 0 plus 4. So you just put that into the calculator and you just find out that negative 2 into 0 plus 4 equals to y, and that is 4. So y equals to 4. So can you see, guys, with linear, how do we determine the equation of the graph, and how we find x and y values? Okay, one thing you have to know, again, maybe you're in grade 10, grade 11, or grade 12 and you don't know this. When you have f at x, when you have h at x, or g at x, or anything that the examiner might decide to use, these things are y. It's equals to y. So you see f at x, it's y. You see h at x, that is y. It is standing for y. They could have said y equals to mx plus c. But with functions, they use f at x, h at x, g at x. These are the commonly used ones. Just like I have shown you here, it's y equals, we can say f at x, or g at x, or h at x equals to mx plus c. Now let's say you are given this, and they say this is the equation of the line. You have to put it in a standard form. So what you have to do, you have to divide by 2 on both sides. So y equals to 2x plus 4. So this is the standard equation of a straight line. This is how it has to be. Another thing that you have to do, guys, is that gradient of parallel lines is the same. So let's try to maybe draw this graph that we have here. We have line AB and line CD. So let's start with A1, or let's say 2, 4, 6, and then we have those in between. Here is 2, negative 2, negative 4, negative 6, and then is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see, 6. Now for A, when x is 3, positive 3, y is 2. And then for B, this is A. For B, when x is 5 somewhere here, then b is 4. This is b. Let's say maybe this line goes like this, or I just go like this, it's fine. So let's go for c. When x, no, this is 1 2 3 4 5, -1 -2 3 4 and 5. So when c is -1, y is a positive 3, so 3 will be somewhere between 2 and 4. And then another thing is that when x is 2, y is 6. So you see, this is that line. So these two lines are parallel. Now, to prove that lines are parallel, if you are given that question, their gradient has to be equals to 1. Now, what is the equation of the gradient? That is y2 minus y1 over x2 minus x1. So let's do for a, b first, and then we can substitute ab as 4 minus 2 over 5 minus 3, and that will give us, and then for cd we can substitute as well as 6 minus 3, and then 2 minus -1, and then for this one we'll get 1, and even for this one we'll get 1, right? 6 minus 3 is 3, 2 minus -1, this is plus, it's 3. So 4 minus 2 is 2, 5 minus 3, it's 2. So 2 divided by 2 is 1, 3 divided by 3 is 1. So another thing is that gradient of perpendicular lines is equals to -1. So the gradient of this line here and this line here, when you times them, they have to give you -1. Even anywhere, even if in analytical geometry, there's where in grade 11 that those rules apply. So every time you have perpendicular lines, this line, the gradient of this line, let's say this is BC and this is DE. So the gradient of BC times the gradient of DE should give you -1. So if you have the gradient of BC and then you have to find the gradient of DE, you will say, all right, yes, the gradient of these two lines, when you multiply them, they have to give you -1. Sorry if I said when you add them. No, it's when you multiply. So this BC, let's say the gradient is 3, and then the gradient of DE, we don't know, but we know that these gradients, when you multiply them, get -1. You see, we can say, well, it be 3DE equals to -1. And what do? You just divide by 3 both sides, and then the gradient of DE would be -1 over 3. You see, this is how you will do it if you have that question. All right, now the next thing we are going to deal with is a parabola. Now, a parabola, when you see something like f at x equals to x squared, then you know everything to the power of 2, it's a parabola, right? Like this one, this equation, this is a parabola. You see this, anything to the power of 2, it's a parabola. don't forget that, guys. These are more parabola equations that you can come across. So anything to the power of 2 is a parabola. Remember, exponential graph is to the power of x. So if we have anything to the power of x, that's when we know that we are dealing with a exponential if it's to the power of x. But anything to the power of 2 is a parabola. And a parabola is a quadratic equation as well. Y equals to x squared minus 3x minus 4. This is still a parabola. Anything to the power of 2, it's a parabola. So please don't get that wrong. So a parabola is either a happy or a sad looking graph, right? So here are the coordinates. You can draw this graph. When you have coordinates like this, wherever you see x, you will write, you start from -2, -1, 0, 1, 2, and then you will go to this. When you substitute this into x, you get this value. Let's say you say -2, -2 to the power of 2, that is 4. And when you replace that 2 with a 1, you will get a 1. When you replace it with 0, you will get 0. When you replace it with positive 2, you get 4. And when you replace it with a positive 1, you get 1. So the outcome of that graph should be like this. So if you have done the graph correctly, you should get this shape. These are the points on the graph. It's a happy face, and when it's facing downwards, it's a sad face. So when there is a positive here, your graph will be like this, and when this is negative, your graph will face downwards like that. All right. Sorry guys, it looks like we were not recording. So how to draw a parabola? You need x and y values. So y equals to 2x squared. Let's say this is the equation we are given, and we need to draw a parabola. We're given this, so we need to get x and y values. Just like I've shown you, to get y, x should be 0. To get x, y should be 0. So now we're going to try to get the x values. We'll say 0 equals to 2x squared minus 8. So we'll move this 8 this side. Here it is going to be positive. And then we'll have 2x squared here. Divide by 2 to get rid of this 2 so that we can solve for x. And then here will be 4 and x squared. So to get rid of this squared, we have to square root both sides. this square root will cancel this 2, and then when we had a square root, you have to write the answer plus or minus x. So those are the two x values that we need. We need a negative x value and a positive x value. I'll show you how we'll use them on the graph. So it is negative 2 and 0. When you say plus, or when you say minus is equals to minus 2, this is how we do it. When you say it is equals to plus 2, it will be a positive 2 and a 0, right? And then to find y, we make x 0. You just put this inside your calculator like this, and you will get negative 8. So let me show you how you plot. Okay, this is how you plot it. This again is a Cartesian plane. So we got here our positive 2 and 0, and here we got our negative 2 and 0. So those are the two x values. We need two x values, and we need this one, which is 0 and 8. That will be our turning point. So you just draw it like this, and here is your graph. All right, guys, this camera stops recording. So this is there. You're asked to determine the equation of the parabola. You are given this graph. As you can see, this 0 and negative 2 here at y. It means this graph has went down 2 times. Negative, yes. So it will be negative 2. If it went up 2 times, it will be a positive 2 here. And then we have a point A, which is 3 and 0. Point B is negative 3 and 0. Now we are given this graph as we're given this equation as the equation of the parabola, and we have to determine the equation of that parabola. Now this negative 2, this one that is here, we write it, it represents the q. That, just as I have explained, that q means that the graph has went down 3, has went down or up. If it's negative, it has went down. If it's positive, it has went up. So here what to do here, I want to complete that question here. So it's ax squared minus 2, and then it's 0. We're going to substitute any points of the graph. So I have decided to substitute in the equation. So x is negative 3, y is 0. So we have to find the value of a, right? So 3 squared is 9. 0 equals just going to be 9a. A times 3, x squared is going to be 9 minus 2. So this 2 will be positive plus 9a. Let's divide by 9. Then 2 over 9 is equals to a. So we have determined a. So we'll write this equation as y equals to 2 over 9 x squared minus 2. We have determined the equation of that parabola. I hope you're understanding, guys. This is very much easy. You just have to know what you have to do. So this is an exponential function. F at x equals to 2 to the power of x. Here I have given these are the x values, so you can use them to draw the graph. So you just substitute these values here and you will get this ones, and then you will see this. This is a exponential graph. It goes this way. So when you see anything like this, just know that it's a exponential graph. Yes, this is an exponential graph. And if you see dots like this or like this, that is an asymptote. So if you are having like this, that means y equals to 1. If it's on 1 or it's 2, just know that these things are asymptotes. If you see lines, that is an asymptote. So this is an exponential graph to the power of x. Anything to the power of x you see, you know that you're dealing with exponential graph. So just like here, 2 to the power of x plus 2, this is an asymptote, okay? It's an asymptote line. So it will always be on the cutting the y-axis, this. So if it's 2, it's cutting exactly at 2, and the graph is above that 2. If it's 1, if it's negative 2, then it's cutting at negative 2, and the line is above that negative 2 asymptote. All right, let's say you have to determine the equation of exponential graph. We are given this graph here. The asymptote here, it's y equals to 1. So we're given 0 and 4 and 1 and 7, and we having this. You see, this looks similar to a parabola, but a parabola here has to be 2, not x. So we have to determine this equation. Now here is where we're going to do it. You say y equals to ab to the power of x plus q. This q is the asymptote. So what you do is that to get y, x has to be 0, and to get 0, x has to be y. Yes, so as I have shown you this graph, we are going to determine the equation of this graph. I decided to write it here so that I can do it step by step with you guys. So you need the value of a and b. So immediately, as you can see, we have the value of q. Now it is 1, is the asymptote. So the way we determine the equation of an exponential form is very weird, but that's how it's done. So we're just gonna say y equals to a x plus q. We just do away with the b. We'll see it again later. This is how we do it. So we can substitute any points. That will be, let's for y we'll have 4, and then that is a, and then this a will be, yes, so this will be 0 plus q. Anything to the power of 0, it's that same. If you have 3 to the power of 0 is 3, 1 to the power of 0 is 1, a to the power of 0 is a. So we will say 4 equals to a plus 1. Remember, it's the asymptote. We'll move it here. It will be 4 minus 3 equals to a. 4 minus 1 equals to a. So a equals to 3, right? Now we have to solve for b. Then we'll say y equals to 3 times b x plus 1. So we're gonna use this next points on that graph. Then we'll say 7 equals to 3b to the power of 1 plus 1, right? So it will be 7